everyone, welcome back to my channel. This is Trisha and today we're going to learn chapter some basic concept of chemistry for class 11th, and that is CBSE both 2020 to 2021. Now I'm going to call Dr. Nilesh Kumar to teach you. Thank you.
Yes, children, welcome again. Student of class 11th. Normally you have opted chemistry. Very good. Now children, so you all definitely will be dreaming about your career. So point number one, you will be aiming IIT, JEE or CBSE medical exam. So normally, generally, science student of science has first window, that is medical or engineering. So students, so this is a CBSE syllabus. Chapter name, some basic concept of chemistry. This is very important chapter for you also, and we are going to start this chapter. So first we will begin this in terms of syllabus of CBSE syllabus. Okay. Now when we will start this CBSE or syllabus, see, first the topic is general introduction and of chemistry, importance and scope of chemistry, right? Nature of matter, and then next law of chemical combination, concept of atom, molecules, elements, right? So this is a syllabus. So you can see here what is the syllabus. See, this is a syllabus: nature of a Dalton's atomic theory and atomic masses, molecular masses, mole concept and molar mass, and the problem based on it, and percentage composition, empirical formula and molecular formula, right? Stoichiometry and chemicals, and problem based on stoichiometric calculations. So this is the syllabus: empirical formula, atomic and molecular. So this is a syllabus of CBSE 2021 syllabus. Now see, in the below we have written physical quantities and their measurement in chemistry. Physical quantities and their measurement in chemistry, and precision, accuracy, significant figures and calculation of significant figures, SI units and dimensional analysis. See this portion is also available in your NCERT, but at present these two topic is excluded in CBSE syllabus, okay, or NTA NEET exam. Okay, so you can see, refer your syllabus on net also. So this portion is excluded now. Clear? Okay, and it is included in JEE Mains. So JEE point of view, this portion is very important. These two topics: physical quantities and measurements in chemistry, precision, accuracy, significant figures, SI units and dimensional analysis. All right, and this portion you can study in the physical world also. Physics teacher can teach you. It is a part. Now this part has been shifted from the CBSE syllabus. Now we are going to start this chapter, children. So today we will take up topic number one, that is law of chemical combination. See here, this is a topic. Today we will start this law of chemical. This is we have already discussed. So law of chemical combination, this is the part we will start. Law of chemical combination, children. Now see, first I am rubbing this syllabus, children. Now according to law of chemical combination, mostly we deals in chemistry chemical reactions, children. Okay, so mostly we deals chemical reactions, law of chemicals combination. Okay, now in this law, mostly in chemistry we deal the chemical reactions. In fact, chemical reactions are essence of in the chemistry. Okay, so in 18th century our scientists or chemists found that these chemical reactions obey a certain rules. Okay, so these certain rules referred as a law of chemical combination. So children, very simple. So chemical reactions obey strictly certain rule, and this rule obey certain rule. Because of obeying this rule, this law is known as a law of chemical combination. Now we are going to, there are 5 law of chemical combination. Number 1, law of conservation of mass, or we would law of indestructibility in matter. Second law of definite or constant proportion. Third law of multiple proportion. And fourth law is law of reciprocal. Fifth law of gaseous volume, or Gay-Lussac law. So in this way there are 5 laws. Clear? So in this video we will take up first law. This law name is law of conservation mass. Law of conservation of mass. See. So first law of conservation of mass. Children, law is very important. Law of conservation of mass. Okay. Or in other words, law of indestructibility of matter also. Okay. So scientists, this law was proposed by, in 1774, French chemist Antoine Lavoisier, and this scientist also known as father of chemistry. See, French chemist, so, and Antoine Lavoisier, father of chemistry. So according to this law, okay, what it says? Number 1, in any physical or chemical process, during any physical or chemical process, total mass of reactant is equal to total mass of product, right? With before in the beginning of change, right? Now second, this is possible when matter neither created nor destroyed during in physical or chemical change, right? So we can write also the law during in physical and chemical change, matter neither created nor destroyed, however energy it may change into one form into another form. Children, this is a law of conservation mass. This is a statement. Now after this law we can study by very simple example. C plus O2 CO2. Okay, so this is a reactant. Total mass is 12 gram. This is 32 gram. Okay, so 44 gram. Molecular, how to calculate molar mass of any compound? So you know already, this is mass of reactant, product. So this is law of conservation of mass. In ordinary condition, total mass of reactant must be is equal to the total mass of reactant. So you can see this is a reactant side, product side. So 2 to the 4, so 44 gram is equal to 44 gram. So yes, this chemical equation obey law of conservation of mass. Clear? Now next reactions I am going to take up. Next, one more example to make sure clear. So very simple reaction. You can take H2 plus Cl2 reaction in sunlight to HCl. So 2 gram and this is 71 gram. So you will see 73 gram. Totality may you will get this. Okay. So collectively 73 gram. So this equation also obeying law of conservation of mass. So total mass of reactant is equal to total mass of product. Clear? Now next we will come how this in a laboratory. This experiment is also performed by the scientists in lab. Performed in lab. Landor scientist. Landor's scientist or experiments. See, in this state we will take, this is a hydrogen, similarly to hydrogen. Okay, this limb consists sodium chloride solution. It contains silver nitrate solution. So left limb and right limb contain, these are the reactant. It is shifted from this side. Now it is closed. Okay, seal it. After seal it, take it, invert this. After inverting, mix up. After mixing, you will see white color appears. Precipitation reaction is there. So children, see the chemical reaction. Here is, so chemical reaction, NaCl plus AgNO3, NaNO3 plus AgCl. This is a sign of precipitation, solid. So white precipitate. White precipitate is formed. So this is, so according, if it is clear, so total mass, if case total mass of reactant, at last he found total mass of these reactant side is equal to the total mass of product. So in this way, this law is verified in laboratory also, checked by the Landau's experiment. This is hydrogen like apparatus filled, and this is. Now the next, what is the limitation of this experiment, students? Next topic, limitation. Limitations of this. See, limitation is very simple. You know, in ordinary reactions, in ordinary condition, there is a physical change, physical and chemical change. So this law is applicable, right? Now in the beginning of 19th century, Albert Einstein entered and he worked how mass is converted into energy, right? So this is a limitation, when mass is converted into energy. Okay, so E is equal to mc square. According to this, every mass can convert it into energy. So in very special condition, if mass is converted into energy, so children, this law cannot be, so this law of conservation mass is not applicable, is obeyed in this situation. So this is a limitation. Now in physical, in ordinary condition, okay, change in physical chemical changes there, total mass of reactant is falling. So in that situation, law of conservation mass is applicable. So in students, see, in this mass defect, to in nuclear reactions, okay, no law of conservation mass. Okay, so nuclear reaction, nuclear fusion, nuclear fission is there. Okay, so children, this is a limitation of law of conservation of mass. Now next is, we are taking up one numerical on this. All right, we are taking up numericals on this, children. So see this numerical, we will take up one numerical. So 4.9 gram potassium chlorate when pyrolyzed, and its residue gives 1.93 gram, 1.92 gram, and calculate the mass of oxygen gas released by using law of conservation of mass. Law of conservation of mass. So this is a numerical problem, 4.9 gram. Okay, so children, very simple it is. 4.9 gram we will take, right? So it is producing 2.96 gram residue. Now, before attempting this question, we need to write a chemical reaction. Without this is not possible. Potassium chlorate 2 KCl plus 3,2. Now, in total mass of reactant is equal to total. It is written law of, there is a application of law of conservation of mass, we know, concept we know. Total mass of reactant is equal to total mass of product. So the value is given here 4.9 gram and 2.96. Here we will assume X. So total mass of reactant is equal to total, applying law of conservation of mass. So total mass of reactant, is equal to mass of product. So see this, 4.9 is equal to 2.96 plus X. So X is equal to 4.90, 2.96, 4, right? So the value will come 1.94. 1.94. So the value will come 1.94. Yes. So point this. Now value will come 1.94 gram. So you can put. So see this. Verify this law. 4.9 gram is equal to 2.96, 1.94. So 460, 918, 4.9 gram. So 4.9 gram is coming. It means it is obeying law of conservation of mass. Law of conservation of mass. So total mass of reactant is equal to total mass of product. Numerical is very simple. 4.9 gram. Here is a use of, in concept of, we should know the concept and techniques and then application, right? So here we are doing three things: concept, techniques and application. So through the numericals we can use of techniques and concepts. Okay, so children, 4.9 gram of potassium chlorate when pyrolyzed, okay, it gives residue, and reducive mass is given, that is 2.96 gram, and calculate the mass of oxygen release by using law of conservation mass. So concept is this: total mass of reactant is equal to total mass of product. And first write the chemical equation, calculate and assume the value of oxygen X, like draw equation, get the value of X and equate it. If the total mass of reactant, here total mass of reactant is equal to total mass of product. So in this way, this chemical reaction is strictly obeying law of conservation of mass. So children, so we have now recap conclusion of this video. Number one, we have studied syllabus. Okay, you of the some basic concept of chemistry. Right? What is the which portion is deleted from this CBSE and CBSE NEET or JEE Mains में few points topics they have added now. Okay, so syllabus and we have started take up the topic law of chemical combination. First law we have this studied. We have learned first law, that law is law of conservation of mass or law of indestructibility of matter. Okay. So then we have worked verified by the statement of law of conservation of mass, and then by taking up with a few chemical reactions, verification of law in laboratory by Landau's experiment, and then limitation of law of conservation of mass. Clear? And then we have had solved one numericals on this. Okay, children, thank you in this. So we will see you in the next topic, that is law of definite composition. Okay.